All right, let's dive right in. We're talking about C++, one of the most powerful, respected, and feared programming languages on the planet. We're going to cut through all the noise and give you the real deal, no fluff guide to taming this beast with modern professional techniques.
And this right here just nails it. C++ is not a toy. It's an industrial-strength tool that gives you absolutely mind-blowing performance, but it demands respect. And more than that, it demands you understand how to use it safely in the modern era. And that's exactly what we're here to do.
So here's how we're going to break it down. First, we'll look at the core trade-off, the power and the peril. Then, we'll cover the single most important concept for safety, something called RAII. After that, we'll zoom out to the wider ecosystem and wrap up with the mindset and tools that really separate the pros from the amateurs. Let's get started.
Okay, Section 1. This is all about the fundamental bargain you make when you choose C++. Why is it the go-to language for everything from AAA games to high-frequency trading? And what's the catch? What's the hidden danger that comes with all that power?
So here's the deal with C++. It gives you total control, you're as close to the hardware as you can get, and its powerful features, these abstractions, they don't cost you a single cycle at runtime. But the price you pay for all that speed and control is safety. The language fundamentally assumes you're an expert. It trusts you completely, which means it's on you to build in the seatbelts and the airbags.
And this is the monster hiding in the closet. It's called undefined behavior, or UB. Now, if you break a rule like reading past the end of an array, you'd think your program would just crash, right? Give you a nice error message? Nope. With UB, the compiler is allowed to do anything. And I mean anything. It could work perfectly fine for months and then suddenly start corrupting your data silently. It could even look at your safety check code and decide to just delete it. It is, without a doubt, the most dangerous thing in all of C++.
Okay, but it's not all doom and gloom. Far from it. That brings us to the solution. This next part is about the single most important idea in all of modern C++, the one concept that tames the language's most dangerous parts. It's called RAA.
So, to really get why the new way is so good, you have to see the old way. For years, C++ programmers had to do everything by hand. You'd ask for memory with new, and then you had to remember to give it back with delete. If you forgot, even once, in some obscure error path, boom, you've got a memory leak. It was a total tightrope walk and super easy to mess up.
So the modern answer to this chaos is just beautiful. It's called RAII, Resource Acquisition is Initialization. Yeah, it's a mouthful, but the idea is pure genius. Instead of you remembering to clean up, you tie the resource, like memory, to the lifetime of an object. You create the object, it grabs the resource. And because that object lives on the stack, the language guarantees, and I mean guarantees, that when it goes out of scope, its cleanup code runs automatically. No leaks, no forgetting, it's automated safety. And this right here says it all. It's night and day. On the left, you've got the old way, a raw pointer, a manual new, and the constant fear of forgetting to delete it. On the right, the modern way, STD make unique. It gives you a smart pointer that owns the memory. When that pointer goes away, the memory is freed, period. You never write delete. This is the absolute foundation of safe, modern C++.
And you want to know the best part? All this safety costs you absolutely nothing. A unique pointer is literally the exact same size as a raw pointer. It has zero performance overhead. It's a true zero-cost abstraction. For 99% of cases, if you need memory on the heap, this is what you use. End of story.
All right, so we've tackled memory, which is huge. But this philosophy of safety and automation, it doesn't just stop there. It extends across the entire modern C++ library. Let's take a look. Let's talk arrays. The old C-style array on the left, it's basically just a dumb block of memory. It has no idea how big it is, and it will happily let you write way past its end, causing that undefined behavior we talked about. But the modern STD vector, oh, it's a lifesaver. It grows when you need it to, it always knows its size, it has a ton of useful functions, and it can even check if you're going out of bounds.
So the rule here is simple. Just like unique PTR is your default for memory, STD vector is your default container. You always start with it. Why? Because all its data is packed together in one continuous block of memory, which is incredibly fast for modern CPUs to access. So unless you have a very specific reason not to, you use a vector.
And modern C++ isn't just safer, it's way more expressive. Check this out. This thing here is a Lambda function. It's basically a little nameless function that you can define right where you need it. So here, instead of writing a whole separate function just to tell sort how to compare two numbers, we just write it right inside the call. It's clean, it's concise, and it's powerful.
All right, for our last section, we're going to shift gears a bit. Because writing professional C++ isn't just about knowing the syntax, it's about a discipline. It's about a mindset, and crucially, about using the right tools for the job.
Look, I'm going to be blunt here. You can't write professional C++ with just a text editor and a basic compiler anymore. You just can't. The language has too many subtle traps that even the best compilers can't always catch on their own. The pros rely on an entire ecosystem of tools to keep them safe.
And these are your secret weapons. They're called the sanitizers. You just flip a switch in your compiler, and they add checks to your code that run while you're testing. ASAN will scream at you if you make a memory error, TSAN finds impossible to spot bugs in multi-threaded code, and UBSAN catches all sorts of other nasty stuff. Running your tests with these on is absolutely non-negotiable. So, this is it. This brings it all together. This is your manifesto for modern C++. It's a set of simple rules. No more manual new and delete. No more C-style arrays. Use the modern, safe alternatives. Always mark things as const if you can. Turn your compiler warnings all the way up and treat them as errors. And of course, run your code through the sanitizers.
You know, we started by calling C++ a razor-sharp tool. The old way of using it was like juggling that razor with your bare hands and just hoping you didn't get cut. The modern way, well, it gives you the safety gloves, the protective goggles, the whole setup. The power of the razor is still there, but now you have the tools and the discipline to control it. So the only question left is, are you ready to pick it up?